This is part 1 of the video notes for Objective 4B, Geometric Sequences and Series. Just like in 5A, we're going to begin with what is a geometric sequence. So a geometric sequence is any one with a common ratio, R, which is the ratio of every term, or specifically the nth term to the nth minus 1 term. So an example of a geometric sequence would be 1, 2, 4, 8, ... This sequence has a multiplication pattern of times 2, so it has an R, or common ratio, of 2. An arithmetic sequence also has a common ratio, except an arithmetic sequence has not a common ratio, has a common pattern, but an arithmetic sequence has a common difference. This sequence adds the same amount every time, and if you attempt to make a ratio, you'll see that it's a different amount each time. So if you make a ratio of the second term to the first term, the third term to the second term, and the fourth term to the third term, you don't get the same common ratio, which means this is not a geometric sequence. Geometric sequences don't have to be whole numbers. They can be fractions, they can be decimals. So another example of a geometric sequence would be 1, 1/3, 1/9, 1/27. In this case, if you divide these terms, you end up with an R value of 1/3, which is the common ratio. Some things that look geometric in nature but actually are not. So other fractions, for example, 1, 1/2, 1/3, 1/4. If you attempt to do a ratio, 1/2 over 1 is 1/2. 1/3 over 1/2 is 2/3. And 1/4 over 1/3 is 3/4, and you don't get a common ratio. So when you're evaluating geometric sequences, you're really looking for this multiplying by a constant amount each time, and that constant amount is referred to as the common ratio. Because geometric sequences exhibit a multiplication pattern, repeated multiplication is an exponent, and a geometric sequence can be modeled with an exponential equation, an equals a1 times the common ratio n minus 1 times. You basically take your first term and multiply it over and over and over again by the pattern until you get to the term that you want. So we are going to find the nth term and find the 10th term of a couple different geometric sequences. The first one being this. So in this example, the first term is 8. And then the pattern, to get from 8 to 12, 12 to 18, it doesn't look like it has a pattern. You can see that it adds 4, and then it adds 6, and then it adds 9. But if you create the ratio of terms, 12 divided by 8 is 3/2. 18 divided by 12 is 3/2. And 27 divided by 18 is also 3/2. So the common ratio is 3/2. This is the equation for the nth term of the sequence. Then it asks us to find the 10th term of the sequence. So we're going to do 8 times 3/2 to the 10 minus 1 power. Use a calculator. 1.5 to the 9th power, then times 8 is 307.5 approximately. And so let's change to an approximate equal sign. For our next example, we're going to be looking at a first term of 10 and a common ratio of 1/10. And all we have to do is put this into the explicit geometric sequence formula. 10, 1/10 to the n minus 1. Now, unlike the last problem, this one technically could be simplified, so I want to show you some other versions of this equation that would also be correct. For example, 10 can be rewritten as 1/10 times 1/10 to the n minus 1. And if you apply the product rule, this has an exponent of 1, and this has an exponent of n minus 1. So the product rule says you can, if the bases are the same, that you add the exponents. If we add 1 and n minus 1, we get 1/10 to the n power. So this is another version of the explicit formula for this sequence. Simplifying in the other direction, instead of turning the 10 into the 1/10, what if we turn the 1/10 into a 10? We get 10 times 10 to the negative 1 to the n minus 1. Using the power rule, we know we can multiply these exponents. We get 10 times 10 to the negative n plus 1. Get a product rule going on where we add the exponents, and we find that this equation can also be 10 to the negative n plus 2 power. So what's the question asking us for? We want to find the fifth term of this sequence, and I'm going to use this version of the equation. So we're going to find 10 to the negative 5 plus 2 power, or 10 to the negative 3 power. You can use a calculator. Make sure you switch your answer into a fraction because the ratio was given as a fraction. And we get an equals 1 over 1,000. Or we're trying to find the fifth term, so let's switch this to say the fifth term. Last example. Example 3, they're giving us the third term and fifth term. They are not telling us the common ratio. So what we're going to try to find is the common ratio for this equation. So let's set up our equation. an equals a1 r n minus 1. This is going to be a3 equals a1 r 3 minus 1. a3 is equal to 6, so I get 6 equals a1 times r squared. On the other side, I get a5 is equal to a1 r to the 5 minus 1, which is 54 equals a1 times r to the 4th. Now, we need to use elimination or substitution method, depending on if we're trying to find the common ratio or if we're trying to find the first term. So in this case, I'm going to try to find the first term, and I'm going to solve this equation for a1 by dividing both sides by r squared. I get a1 equals 6 over r squared, and I'm going to plug that in to the other equation. 54 equals 6 r squared times r to the 4th. That gives me 54 equals 6r squared. Divide both sides by 6. So in this example, the common ratio could be positive 3, or it could be negative 3, and we don't know the terms in between, so we're going to solve this using both possible values of r. Plug them back in for a1. a1 equals 6 over 3 squared, and a1 equals 6 over negative 3 squared. And because 3 squared and negative 3 squared are both 9, it doesn't matter which common ratio we use. The first term is 6 over 9, or 2/3. Let's use this information to write the explicit formula for the nth term, and then to find, what's this one? The 8th term of this geometric sequence. So we actually have two options for an equation. Keep that in mind. We have an equals 2/3 times 3 to the n minus 1, or an equals 2/3 times negative 3 to the n minus 1. And since I'm trying to find the 8th term, we're going to do 8 minus 1 on both of them. So, using a calculator, this is A8 equals 1,458 And this is A8 equals negative 1,458. And that's the answer for example 3. This concludes part 1 of the video notes for Objective 5B, Geometric Sequences and Series. In this part, we focus solely on sequences and using the explicit formula for a geometric sequence. And in part 2, we're going to focus on series and taking a look at the 2 types of geometric series we need to be familiar with.